Integration has to be the most beautiful topic in A-level maths. This question says, find the integral of 8x cubed minus 3 over 2 root x plus 5 with respect to x. So let's have an attempt. Well, first things first, I'm going to rewrite this expression in a nicer format. So I'm going to have 8x cubed minus 3 over 2, and I want to get rid of this root x as a denominator. So I can rewrite it using my index laws as x to the power of minus a half. And then I have my plus 5 with respect to x. So now I can integrate each term individually. So to integrate, I need to raise the power by 1 and divide by the new power. So this becomes, with this kind of integration, one thing people always forget to add is the plus c on the end. Integration is the most beautiful topic in A-level maths.
Perfectly explained video. And I would also agree that integration is the GOAT of maths. Now this video is perfect for year 1 maths, but how can we apply this to year 2 integration? Now the logic that he uses to simplify the expression to convert it into something that we can easily integrate is still valid for year 2 integration. We just have to use more tools to help us simplify it. For example, let's say we have this expression here. There's a checklist that we need to run through. First, we can see that we have a fraction. So the first thing that I think of is using our Lund trick. But since our denominator doesn't differentiate to our numerator, we can't use it. So the next stage is to check whether this is a standard function that we know how to integrate. So is it in our formula book, or is it a function that we've been told to memorize? No. So on to our final step when it comes to trig functions, by the way. And that is using trig identities to convert it into a standard trig function that I do know how to integrate. So in this case, we use the double angle formula to convert the denominator into 2 cos squared x, and that converts to a half sec squared x, which is the standard function that we do know how to integrate, which integrates to a half tan x. And don't forget your plus c. So if you break down your thinking like this, the jump between year 1 and 2 integration isn't as big as you think. So share this with someone who struggles with year 2 integration. See you in the next video.